Okay, everyone, page 95. Okay, we're going to, today is kind of a lot of theory. Okay, and a lot of theory saja lah. Okay, you know what, let's start lah. Sebab saya pun tidak mau lama-lama. Okay, so today we're going to talk about the factors that affect the resistance of a wire, okay, through an experiment that we cannot do yet lah. Okay, but we are also going to talk about a certain formula, which is this formula, R equals to rho, okay, rho as in macam ketumpatan punya rho, except that now this rho means something else, okay, L over A. Okay, so R equals to rho L over A. It's a very important formula when we're talking about the factors that affect the resistance of the wire. So when we talk about resistance of the wire, you must remember that the resistance of the wire is the one that is trying to stop the current from flowing. Okay, so if you take for example a river, okay, satu sungai bahkan, all the batu-batu in the river acts as resistance. Okay, resistance, and the water or the river water that is flowing represents the current. Okay, so begitu juga in the electric wire lah. All the molecules inside the wire act as the stones, okay, to stop the current from flowing. But the current can flow if they have enough energy from the voltage. Okay, so it's this balance between the resistance and the voltage, okay, that causes the current flow. But we need to consider that there are certain factors that affect the resistance of the wire. What makes a wire higher resistance? Apa yang menjadikan satu wire itu kan, dia lebih besar dia punya rintangan, lebih besar dia punya halangan lah. Okay, so you can think of resistance macam halangan, obstacle. Okay, so there are certain factors that affect the resistance of the wire, and we're going to look at this lah. So the first factor, okay, sorry. So when the value of the resistance R is large, okay, all these notes are there. Okay, when the resistance is large, the current is small or large? What do you think? Sorry, anybody? Oh, this is a Gariska. Okay, fine. Let's do number one lah. The resistance of a conductor is a measure of the ability of the conductor to allow, okay, the flow of an electric current. Sorry, resist. Astaga, what did I say? Allow. Resist bahkan. Nama pun resistance, bukan allowance. Kan? Okay, sorry. The measure of the ability of the conductor to resist the flow of an electric current through it. Is it resist or allow? Resist lah kan, nama pun resistance. Yeah. Ability of the conductor to resist the flow of an electric current through it. Yeah. Okay, so from the formula V equals to IR, okay, the current is directly or inversely proportional to the resistance. What do you think? Current and resistance, according to this formula, V equals to I times R. If you want to know whether it is directly or inversely, you bring one side across lah. So V over I equals to R. R on one side and I on one side. So we find that because one is on top and the other one is at the bottom, so it is inversely proportional. Okay, when the value of the resistance is large, the current flowing will be small, and that's very normal lah. Kalau besar dia punya halangan, okay, current that flows will be very small because banyak halangan. Okay, so the question is, what are the four factors, okay, that are affecting the resistance of a conductor? Okay, wow, sebenarnya ada sudah jawapan. Okay, so the first factor is the length. Okay, and we're going to talk about the relationship between length and resistance in a while. Okay. Secondly is the cross-sectional area atau the diameter of the wire, or alias the letter A. Okay. The length is actually represented by the letter L. Okay. You should know this now because we are going to talk about the formula for R later. Okay. Remember, R equals to rho L over A. So this L is a big factor lah. Okay. Now, in the old days, dulu sukatan lama, cross-sectional area merujuk kepada the thickness of the wire. Okay, tapi sekarang kita jarang sudah menggunakan perkataan inilah, but it's also good for us to understand lah. The diameter of the wire, how thick is the wire? The wire is this thick, the wire is this thick, then the resistance will be different. Okay, which we will talk about in a little while. Thirdly is the temperature. I don't know why they put D over there, but we can put it as C if you want. The temperature of the wire also affects the resistance. Okay, and lastly is the material of the wire, the type of the wire. Okay, there are many types of wires. The one that we are commonly seeing, okay, yang kita selalu nampak adalah copper wire. Okay, the one yang kita paling nampak lah. You know, let's say you open the plug, you see the wire. Okay, it looks like copper color. Okay, it's copper wire. Sometimes you will have, you know, slightly higher, like say the light bulb, kan yang mentol. Okay, so over here, so inside here the wire, okay, it's not copper lah. It's made by this material called tungsten. Okay, so tungsten wire, it may have a higher resistance or lower resistance compared to copper. Okay, but we need to talk about, so what if it is higher resistance? Okay, how does it benefit us? How is it useful to us? Okay, so we will talk about that in a while. All right, so length of the conductor. Let's talk about the relevant hypothesis. You can do this as number 5. So the length of the conductor, take a look. The longer the length, okay, notice the resistance. The resistance becomes bigger. And if you take a look at the graph, okay, the graph is directly proportional. Therefore, what is the hypothesis? Okay, the hypothesis will be the length of the conductor is directly proportional to the resistance of the wire, or the bigger the length, okay, the bigger the resistance. Okay, and it makes sense because if let's say you think about, as I said just now, if you think about this length as a river okay, kalau kamu punya sungai begini, atau kalau kamu punya sungai begini panjang, atau kau punya sungai begini panjang, okay, here got less obstacle, here maybe got more obstacle, here lagi lah banyak obstacle, banyak lagi batu yang dia kena lalui. So the longer the wire, the bigger the resistance. Okay, let me repeat. The longer the wire, okay, the bigger the length of the wire, the bigger the resistance. The more resistance you're going to face. Sebab banyak liku-liku perjalanan lah yang itu current kena melalui lah. Okay, the current has to go through so much, okay, just to pass through that distance. So that is the first thing we need to remember. The bigger the length, the bigger the resistance. Okay. Secondly, the cross-sectional area. Okay, cross-sectional area macam saya cakap merujuk kepada dia punya ketebalan. Now, cross-sectional area, okay, kalau dalam dunia kalau macam electrician bahkan, they will use this SWG okay, known as standard SWG lah. SWG is known as standard wire gauge. Okay, standard wire gauge. So when you talk to electrician kan, or if let's say kamu bekerja dengan company electric bahkan, they will just say, give me the 24 wire, give me the 26 wire, okay, because it's easier, kalau diorang tahu 24, 26, 28, 30 begitu. Daripada, cuba konon kau cakap, give me the 0.599mm wire, punyalah panjang mau cakap. Kan? So, take a look at this. When the SWG becomes bigger, look at the diameter. The diameter becomes smaller. Okay, this is an important thing. When the SWG bertambah, diameter dawai akan berkurang. Okay, you don't have to, this is in your textbook but you don't have to really memorize this. You should memorize this The SWG and the thickness of the wire, or the diameter of the wire, okay, is inversely proportional. Okay, but electricians, they will use this kind of terminology. Okay, saya rasa ini kan perlu wire 30 atau ini perlu the 28 wire. Okay, they will not say this will hit the 0.376mm wire. Mana ada, too much, banyak lah kalau mau hafal benda itu. But electricians know that the bigger the SWG, the thinner the wire. Okay, so how does the cross-sectional area, how does the thickness of the wire affect the resistance? Okay, so the bigger the cross-sectional area, okay, the smaller the resistance. Okay, think of two wires with the same length. Satu wire begini tebal dan satu wire begini nipis. Okay, mana satu yang senang untuk elektrik mengalir? Or if let's say you have a car lah, kan, kalau kamu ada kereta bahkan, which one is easier for the car to drive faster? Obviously, it's the thicker one lah. Okay, because there's more space. Okay, whereas if your jalan is so sempit like this, like you very scared you kena the side bar. Okay, so the bigger the cross-sectional area, the thicker the wire, okay, the smaller the resistance. So in terms of SWG, you can say the smaller the SWG, okay, the smaller the resistance. Because SWG and diameter is terbalik. Okay, the smaller the standard wire gauge, the smaller the resistance. Okay, but in terms of cross-sectional area, dia punya luas, dia punya ketebalan, okay, it is inversely proportional. And that's why the graph shows you this lah. Okay, the graph will show you this. Okay, they are the inversely proportional graph. Okay, can I continue?
Yeah.
Yeah. Okay, all right. Okay, so if you take a look at this, okay, V against I, you will find that the thick wire, okay, SWG22, the gradient is much smaller compared to this. But the problem is we actually haven't learned about this graph because we haven't done the experiment. Okay, so please hold on until we finish the exam, then we will do this experiment, then you will know what this experiment is talking about. For now, kita masuk theory dahulu lah. Okay. Wow. Okay, next is the material of the conductor. Okay, now we find that nichrome, okay, a nichrome wire, okay, has a very high resistance compared to silver. Silver has very low resistance. But of course, nichrome is much cheaper lah, okay, compared to silver. Silver wire is very expensive. Apatah lagi gold lah, gold wire. It is said lah, and I'm not sure how true this is. Ada orang cakap yang gold wire actually has very, very low resistance. Okay, but siapa lah yang mau pasang wire emas bahkan di rumah terus kena curi itu. So even silver wire, so even with the low resistance kan, it is still expensive. So that's why people use copper. Because copper is cheap. Okay, copper is cheaper lah than silver and gold. Okay, and if you look at the resistance, okay, look at the resistance, you will find that it has a lower resistance compared to nichrome. Okay, maybe what you can do is you can write a short note over here lah. Okay, in a VI graph, okay, bagi graph V melawan I macam ni kan. Okay, the gradient, okay, the gradient represents the resistance. Okay, so ini adalah graph V melawan I. So look at the 4 different gradients lah. Okay, this one is low gradient. Okay, dia punya kecurangan kurang. Manakala ini adalah high gradient. So because it has a high gradient, okay, the nichrome wire has a very high resistance. Okay, which is good for certain situations, which we will talk about in a while. Okay, silver has low resistance, also good for different situations. Okay, which we will talk nanti lah. Okay, so the resistance of the conductor changes with the material of the conductor. Okay, but these are the 4 most common conductors that we can find lah. Okay, nichrome, constantan, copper, and silver. Okay, there is another kind of material called the eureka material. Look at the resistance lah. It's like super high. Okay, 40 R. All right. Okay, next page. Okay, the resistivity. Okay, come on. Next, the last one tiada. Okay, temperature of the conductor. This one you can write down like at the bottom over here lah. Okay, because the next page tiada sudah itu. Okay, this is an important thing now for us to understand. Okay, the higher the temperature of the conductor, the higher the resistance. Okay, so in another sense, when the wire is hot, okay, it means there is a high resistance. Okay, because okay, why does resistance happen lah? Dia macam seperti kalau itu electricity ya, itu current dengan itu rintangan kan dia bergeser. Let's say your two hands, if you rub your two hands together, okay, they're going to feel hot. Okay, and the more you rub, okay, the more you rub, okay, the more resistance you give it, the more hot your hand is going to feel. And that's exactly what is happening in a wire. Okay, the interaction between the molecules in the wire and the electron flowing, if there's a lot of molecules that are rubbing against the electrons, there's going to be a high resistance. Okay, and because of that, the wire is going to become hot. Because dia selalu berlanggar. Bila berlanggar, semua orang jadi panas. Begitu. Kan? Macam case baru-baru ini. Did you hear about the case about the two LRTs yang berlanggar, terus satu dunia jadi panas. Okay, dia menjadi lebih panas sebab masa press conference, the spokesperson tidak tahu macam mana nak cakap. Terus semua orang jadi panas. Okay, so when there's high resistance, okay, the wire will get hot. This is very important for us to understand. Okay, the higher the temperature of the conductor, the resistance is higher in that wire. And there are good situations for this, and there are not so good situations for this. Okay, we will talk about this in a little while. So the resistance is directly proportional to the temperature of the conductor. Okay, and in which this will be the graph lah. Okay, yang unfortunately dia tidak kasih tunjuk di sini but you can copy this down as the fourth baris in this one. Okay, this yang the third one over here, it says the resistivity of the conductor bahkan. Can you please change this to the material of the conductor? It's sepatutnya the material, bukan the resistivity. Okay, because the third one is material of conductor. Okay, so the last one is temperature of conductor, which is not shown in your notes. Okay, please let me know if I can continue. Now, I'm going to skip the next few pages because it's all experiment, makan. Okay, so let me skip to a few more slides. So we are going to talk about the experiment much later lah. Okay, lepas exam kita cakap pasal experiment. So today we're only going to do just theory. Okay, please turn to page 100. Okay, turn to page 100. We want to talk about the resistivity formula. Okay. Page 100, we're going to talk about the resistivity formula. Hold on, let me share my screen again. I don't know kenapa saya rajin betulan ni. Okay, so we have said, are you guys there? Okay, page 100, can you see this one, the discussion part? Okay, all right, so based on the two relationships that we saw just now, okay, the resistance and the length of the wire, we said that according to our theory just now, the longer the resistance, the longer the wire, the longer the resistance is directly proportional. Okay, so R is directly proportional to L. Dan in terms of the cross-sectional area, okay, luas keratan rentas, the thickness of the wire, it is inversely proportional. Okay, so R is inversely proportional to A. So when we combine this together, okay, we will get R is directly proportional to L and inversely proportional to A. Okay, R is directly proportional to L and inversely proportional to A. Now, if we want to change this into a formula, we have to take this directly proportional ini, tukar pergi sama dengan, dan letak satu pemalar. We put a constant over there. Okay, so the constant is called rho, which we call the resistivity. Okay, dalam bahasa Melayu it's called kerintangan lah. Okay, but it's resistivity. Okay, so the relationship okay, between L and A, okay, and R, okay, the relationship between R, L, and A is connected by this number, okay, which is a constant yang kita panggil sebagai the resistivity of a conductor. Okay, and so because of that, let's talk about what is the resistivity of the conductor. Okay, the resistivity of a conductor is a measure of a conductor's ability to oppose the flow of the electric current. Okay, sejauh manakah dia boleh menghalang, menghalang aliran arus. It's different from resistance. Resistance is R. Okay, resistance is kebolehan. If you remember reading just now, the resistance is a measure of an ability, to resist the current flow. But the resistivity is the conductor's ability to oppose the flow of electric current. Dia macam hampir sama tetapi tidak sama. Okay, it looks like it's the same thing. Okay, but it is different altogether. So the unit of resistivity is ohm meter. Okay, ohm m. Ohm. Okay, ohm m lah. Okay, ohm m. So the value of resistivity depends on two things: the temperature and the nature of the conductor material. Okay, jenis wire. Okay, and then you will find this one over here lah. So the formula is, since R equals to rho L over A, I can find the value of rho by moving the A up. So saya dapat RA over L. Okay, so the unit SI, the SI unit will be ohm meter. Okay, and so it's important for us to membezakan antara resistance and resistivity. Rintangan dan kerintangan. Kerintangan is rho. Okay, kerintangan dia bergantung kepada the cross-sectional area and the length of the wire. Betul lah. And also the temperature and the nature of the conductor material. Okay, there's quite a lot to study here, so let me know when you are done. Okay, so the resistivity, of different conductors at temperature of 20 degrees Celsius. So whenever the temperature is different, the resistivity becomes a little bit different. Okay, so you have five different materials. Okay, you have tungsten, you have constantan, you have copper, you have iron, and you have nichrome. Now take a look at the resistivity values. Okay, compare the resistance of 5 types of materials. So we find that the high resistance wire is nichrome, and tungsten. Look at the value, 4.9 and 100. Okay, 100 is like very high lah. Okay, so the resistivity and resistance is also directly proportional. The bigger the resistivity, the bigger the resistance. Manakala iron, constantan, and copper, these three, have quite low resistance wires. Okay, take a look at iron. Iron is 0.1 and it's very low resistance. Okay, but also very expensive lah. Okay, so the value of resistivity is over there for you. Okay, you don't have to memorize the value of resistivity. Every resistivity value usually is given to you. Okay, but sekadar cukup untuk kita mengetahui lah bahawa sebenarnya the resistance of the wire is actually impacted by the resistivity. Dia punya kebolehan untuk menghalang. Okay, and it is and the factors that affect the resistance, are the 4 factors that I said just now lah, which is the length, the cross-sectional area, the temperature of the wire, and also the type of material. Okay, but type of material memang merujuk kepada the resistivity. We find that certain materials like constantan, copper, and iron, and silver, which we saw just now, has very low resistivity. Okay, senang untuk arus mengalir. Okay, which is good for certain situations. Tungsten and nichrome have very high resistivity. Okay, susah untuk arus mengalir. And we said just now that things with high resistance will always have high temperature. Okay, which is good also for certain situations. Okay, which we're going to talk about now lah. Okay, so let's talk about how resistivity and resistance is useful for us. Okay, so for heating element, for example, let's say if you have an oven. Okay, if you have an oven, you will see a wire down there, and it's a very tebal punya wire lah. Okay, or even yang cerek electric. You know the coil in the cerek electric, the one that you see there? Okay, that's called a heating element. Dalam bahasa Melayu, it's called element pemanas. Okay, elemen pemanas sebab dia punya tugas adalah untuk memanas lah. Okay, toaster, oven, itu semua ada ini. So the energy change, perubahan tenaga will be from electrical energy to heat. Okay, and we almost always use nichrome, okay, because of its high resistivity. Kita mau itu haba. We want the heat. Because it is the heat lah yang boleh bikin kamu punya cake, cheesecake, your burnt cheesecake, Basque burnt cheesecake atau apa. It is the heat that we want. Kita mau itu the heat lah. Okay, so we want it to be high resistivity. So nichrome, you will find that these wires are usually made of nichrome because nichrome has very high resistivity. Okay, so very good lah. So list electrical appliances which use heating element. So we have two over here, which is electric oven, iron. Iron also use heating element. Okay, electric kettle, hair dryer. Ini semua ni memerlukan elemen pemanas because kita mau udara panas, kita mau untuk membakar kek, semua inilah. Okay, so in order to do that, we will use nichrome wire. Nobody uses silver wire or silver element pemanas because the resistance is so low, susah untuk dia mengeluarkan haba. Okay, so you almost always use nichrome. So state the characteristics of a material for heating element. It must have high resistivity so that it can produce a large heat, and it must have a high melting point. Okay, dia punya takat lebur mesti tinggi so that it does not melt easily. Because that's the last thing we want to happen kan. Kau kasih panas-panas kamu punya cake, kau kasih bakar-bakar kamu punya cake, and then suddenly the element pemanas sudah cair. Like apa? Okay, so it's like that cannot be lah. Okay, so one very important thing about high resistivity is the use of it for heating elements. Okay, we use it in a lot of things. Okay, so later when you iron your baju, well, bila lah kau mau iron baju kan? The next time lah you iron your clothes, the next time you use your oven, next time you use the electrical kettle, or for those of you who still have hair, the next time you use your hair dryer, remember, inside the hair dryer, there is this nichrome element, heating element, okay, yang menyebabkan the hot air to flow, and then wow, my hair can dry very easily. Okay, my hair can dry very easily lah, obviously. Okay, sebab, well, tengoklah. Okay, let me know when I can move on. I hope to try to finish until page 102 today. So, cepat-cepat salin lah. So, nichrome wire, okay, this is given lah. Okay, it's an alloy. Okay, so there, if you remember your chemistry, so alloy is a mixture of two or more elements. Okay, so nichrome is made of two, which is nickel and chromium. Okay, nickel is Ni, chromium I think is Cr or something lah, I'm not sure. Okay, so it has high resistivity. It's about 100 times 10 to the power of negative 8 ohm meter at 200 degrees Celsius and high melting point. Okay, it takes 14,000 degrees Celsius to melt nichrome. Okay, that cause no corrosive at high temperature. Corrosion is macam pengaratan lah. Okay, atau hakisan. Okay, and experience small expansion when heating. Okay, so this property makes it the most efficient heating element. Okay, in your electric kettle, in your rice cooker, ini semua adalah nichrome. Okay, nichrome. All right, next thing is your electrical wiring at home. Okay, so we use copper. Okay, we use copper because it has low resistivity, which prevents the wire from heating up too quickly. Okay, we use copper, low resistivity sebab dia tidak cepat panas. Otherwise, next time kamu mau cas kau punya telefon kan, terus itu wire menjadi panas. That's not very good lah. Okay, then you kind of know that, maybe orang yang buat ini pemecas ini kan, dia tidak menggunakan copper sebab the wire pula yang jadi panas. Okay, so be very careful next time you buy cheap charger. Okay, maybe they're not using copper, they're using something else which has high resistance. Okay, next, fuse. Okay, so the fuse is found over here in your plug. Okay, and where can the fuse be found? It can be found on the main switchboard. Okay, dalam the switchboard in your house. Okay, and also in the plug. Okay, what is the function of the fuse? The function of the fuse is to control exceeded electric current so that no damage of electrical appliance and no burning happens. Let's say the fuse is the fuse limit, if you can see over here, the fuse limit says 5 amps. But then suddenly something happened and then the current flow into your hair dryer or your laptop, the current flow suddenly become 10 amps. Okay, so what happens is the fuse will stop the current from flowing because dia dapat detect oh, there's more than 5 amps coming in. Okay, so it will putus. This thing will putus, okay, to make sure that there's no current flow. Okay, because if let's say your electrical appliance kan dia hanya boleh terima 5 amps and then suddenly 10 amps masuk bahkan, what is going to happen to your alat electric? It's going to explode because so much current is coming in suddenly. Okay, and that has happened before. Actually, it happened to my house before. Okay, somebody was digging somewhere and then caused the electricity current to suddenly shoot up naik lah. So my fan was turning at number 1, you know. Okay, that time it's still quite cold lah. So saya punya rumah kan, saya punya fan kan nombor 1. Tapi tiba-tiba suddenly no reason kan, the fan went as if it's number 5, you know. Then I went to check my fan lah. Okay, masih lagi nombor 1, tapi kenapa ni laju betul? And then suddenly, boom, my fridge exploded. Okay, my fridge exploded because there was so much current coming in. Okay, and the fuse, okay lah, my fridge didn't explode lah. It's the fuse inside the fridge lah. The fuse inside the fridge, dia meletup because there was so much current suddenly coming into the house. Okay, but nasib baik lah, saya punya fan masih berfungsi lah. Okay, and that has happened to me once or twice lah. Okay, suddenly my fan, I thought it was a ghost or something lah, you know, like cepat-cepat memusing itu kipas. No lah, it's just, it is what we call an electrical surge lah. Okay, suddenly a lot of electricity is coming into the house. Okay, for don't know what reason. Okay, so a fuse is very important. Okay, it will control the electric current flow so that your electrical appliances are safe. Okay, that's why whenever we buy electrical stuff, right, we try to buy things with 3-pin plug. Usually 3-pin plug got fuse one. If it is just 2-pin, usually got no fuse lah. So it's a little bit scary. Okay, but even so, there is actually a fuse on the main switch in your house lah, which also does the same job. Okay, if suddenly there's a lot of electricity coming in, it will turn off by itself. Okay, it will cut the power for you. So what is the characteristic of a material for fuse? So the wire used is very thin, with very low resistivity and has a specific melting point that will melt when exceeded current flows through it. That's how this fuse wire boleh putus, because the melting point is not very high. Okay, so if there's a lot of current suddenly coming in, the wire will become very hot and it will melt. When it melts, okay, it will break. Okay, dia akan putus lah. And bila dia putus, your electrical appliance will become sick. Okay, and that's a good thing, you know, guys, because fuse is less than RM2 per fuse. Okay, bayangkan kalau kamu guna LCD, okay, dan yang tiada fuse. Okay, maybe it's cheap lah, tetapi kalau LCD tu rosakkan, kau kena bayar lagi beratus-ratus ringgit. Okay, it's better to change the fuse. Fuse is only less than RM2 per fuse. Okay, so you can change it many times. Okay, can I continue? Are you guys done copying?
Yes.
All right. Next, the value of resistivity form conductor, non-conductor, semiconductors, and superconductors. Okay, so we're going to talk about these 4 kinds of materials. Okay, conductor, non-conductor, semiconductor, and superconductor. Okay, so first, non-conductor. Non-conductor is a material that does not conduct electricity. It is a good insulator. Ini adalah perkataan lawan bagi conductor. Okay, pengalir dan penebat. So insulator is a penebat. Okay, so it does not allow electricity to flow through it. Okay, so in terms of resistivity, it has the highest resistivity lah. So dia tidak membenarkan arus elektrik mengalir melaluinya. Okay, and good examples of non-conductors are plastic, wood, stone. Okay, all these are non-conductors. The human body is a conductor. Okay, jangan juga kamu cakap the human body is a non-conductor. Tidak. Okay, we are conductors. Okay, otherwise, you know, how do people get electrocuted lah? Macam mana orang boleh kena renjatan elektrik? We are conductors. Okay, we are not plastic and definitely we are not kayu. Jangan juga kau perasan. Okay, semiconductors. The word semi, the word semi means half. So dia seperti conductor tetapi seperti juga non-conductor. It is a material that conducts electricity better than an insulator but not as good as a conductor. Okay, and we are going to study semiconductor in chapter 5. Okay, chapter 5, yes, chapter 5. Okay, we will study semiconductors in chapter 5. But this is a good time to introduce to you what semiconductors are. They are half conductors. Not as good as conductor sebenar, but definitely better than insulator. So in terms of the resistivity, dia punya resistivity is between a non-conductor and a conductor. So dia semicon lah. Okay, semiconductor. So examples of semicons are silicon and germanium. These are two important elements in a semiconductor which we will see in chapter 5. Okay, now kita fokus kepada conductor dulu, conductor and superconductors lah. Okay, silicon and germanium. Let me know when I can continue. So, conductors. Okay, conductors is a material that conducts electricity. Okay, so in terms of resistivity, it has generally quite low resistivity lah. Okay, compared to insulator. Insulator has very high resistivity. But of course, even in conductors, dia punya resistivity ada perbezaan. Okay, nichrome and silver are both conductors, but nichrome has a higher resistivity. Okay, silver has low resistivity. Tetapi secara amnya, all conductors have low resistivity. Okay, and some examples are iron and carbon. You can also put nichrome and copper. All these are conductors lah. Okay, now the last thing is called superconductor. So dia band paling tinggi lah. So non-conductors, okay, or insulators, then semiconductor, and then conductor, and then lastly is superconductor. Okay, a superconductor is a material that conducts electricity with no resistance at all. Most conductors, dia akan ada resistance itu. Dia memang akan ada penghalang. But superconductors, nama pun super. Okay, dia adalah super pengalir. Okay, superconductor, dia memang tiada resistance. No resistance whatsoever. It's pretty amazing. Okay, it's good technology today to use. Okay, which we will talk about in chapter 4 lah actually. Okay, tapi kita sebut juga di sini di chapter 2. It is a material that conducts electricity without any resistance. Okay, so in terms of resistivity, zero. Tetapi dia ada syarat. Okay, dia adalah zero resistivity. Okay, zero resistivity at a critical temperature. Pada satu suhu critical. Okay, at a critical temperature, a superconductor will conduct electricity with no resistance. Okay, so dia memang ada syarat. Dia bukan forever and always zero resistivity. Tidak. Okay. Kalau dia belum lagi sampai the critical temperature, dia akan seperti conductor juga. Tetapi at a certain temperature, dia akan dapat mengalir dengan zero resistivity. Okay, and an example of a superconductor is this one, cesium. Okay, jangan juga kau sebut calcium, okay, cesium. C-A-E-S-I-U-M. Cesium at 1.5 Kelvin. Okay, 1.5 Kelvin is pretty low lah, negative don't know how many degrees Celsius. Degrees Celsius change to Kelvin is plus 273. Yeah, minus don't know how many lah. Okay, 1.5 Kelvin or lower. So cesium is one of those things that have superconductor. Okay, and we use superconductors in this thing. This is a MRI machine. Okay, MRI yang kita gunakan untuk, yang kita panggil scan otak, scan badan itu semua lah. Okay, so there are examples of non-conductors, semiconductors, conductor and superconductor in your notes. Okay, if you can see over there. So the non-conductor is the plastic cover, semiconductor is a silicon chip, conductor is a nichrome, the heating coil over here, and the superconductor is this. Okay, in an MRI. So in an MRI, you have this ring of superconductors, okay, that will conduct electricity without any resistance. Okay, so superconductor. Let's talk a little bit more about superconductor. So a superconductor is a material that has zero resistance. Okay, for example, certain metals and ceramic and inorganic material can conduct electricity efficiently at specific temperatures. Certain temperatures, they can conduct electricity efficiently means low resistance. Okay, or no resistance. These materials have no electrical energy loss in the form of heat, sound, and others. This is what it means, If kalau satu wire itu kan, dia boleh mengalir tanpa resistance, that means they will not produce any heat, they will not produce any sound, they will not produce any, there's no energy change. It's just purely electrical energy. Okay, and that's a good thing lah, because sometimes, especially kalau high resistance kan, you will lose energy in form of heat. And electricity change to heat energy. Sometimes you don't want that to happen. Okay, so superconductors are good because they have zero resistance, so there's no energy loss. So this graph shows that when the temperature of the superconductor decreases, okay, bila temperature of the superconductor decreases, the resistance also decreases until you achieve a specific temperature, which is known as the critical temperature, suhu genting. Okay, so the critical temperature is achieved when the resistance suddenly drops, okay, to zero. Oh, please add the word to zero. Okay, so critical temperature is where the superconductor is able to conduct electricity with zero resistance. Okay, and that's why the MRI is very useful. And certain superconductors are useful in certain areas in daily life lah. Okay, one example that you saw just now is the MRI machine yang digunakan untuk men-scan, men-scan badan. Okay, we will look at other examples when we look at chapter 5. But this is basically the 4 types of conductors. Okay, non-conductor, semiconductor, conductor biasa, okay, dan superconductor. Okay, and the best part about superconductor is there no resistance. Tetapi dengan syarat, it must be at the critical temperature. Oh, is that it? Oh, sorry. Okay, so all conductors, I'm not sure where this is going, but never mind. Let's talk about this now. So all conductor material have resistance. The resistance causes loss of energy. Okay, just let's just go through this. I don't think your notes is this one now, but it's just extra information lah. So in 1911, this guy called Kamerlingh Onnes investigated the resistance of this material called mercury. Now he discovered when mercury was cooled to a temperature of 4.15 Kelvin, okay, the resistance suddenly dropped to zero. So mercury became a superconductor at this temperature, 4.15 Kelvin. It's like, negative 269 degrees Celsius lah. Okay, very, very low. Okay, someboy juga dia tu. Okay, Mr. Onnes. So he found that this is what happens. So mercury is also a kind of superconductor. Okay, but you have to freeze it. You have to make sure that the temperature is so low, okay, at 4.15 Kelvin, then the resistance will drop to zero. Okay, so this is an example of a superconductor. Okay, there are materials that conduct electricity without any resistance. So no energy is lost, okay, when the current flows through the superconductor. Okay, so when you put a superconductor near a magnet, oh no. Okay, so this is already chapter 5 lah, but we're going to talk now. When you put a superconductor near a magnet, I saw this on TikTok the other day, by the way. Okay, there is going to be a superconductivity effect. Okay, just listen to this lah, guys. Okay, just listen to this. Okay, so there will be a arus arohan. There will be a current. Okay, there will be an induced current that will flow between the superconductor and the magnet. That will cause the superconductor, okay, to float above the magnet. Okay, and this one, okay, is the basis of all our speed trains. Okay, for example, in Japan, okay, in Japan, the speed train is called the Shinkansen lah. Okay, now the Shinkansen uses this technology, which is called the maglev technology. Okay, it's called magnetic levitation. It is basically an interaction between the magnetic train track and the superconductor in the train. Okay, that causes the train to seperti dia adalah terapung di atas the train track. And when it is terapung, then there's no resistance. That's why the Shinkansen can move very, very fast. That's why it's called a speed train. Because dia sangat sikit dia punya resistance. Okay, it can maintain high current, loss of power is too small, and there's no energy loss.